Hello guys, welcome to another LeetCode problem coding session, binary tree maximum path sum. This is LeetCode 124. We are solving blind 75 LeetCode questions. We are in the tree section and we are solving this binary tree maximum path sum. This problem is a hard difficulty problem in LeetCode, but if you are comfortable solving any of the recursive problem we discussed before, it's not that much complicated problem. You can take a look at the other video I created. So mainly for post order, pre-order, and in order. And if you know how this whole post order works, then it's not that much tough problem to solve. But there are a few key things we need to keep in mind. So we'll go through in detail. So for this problem, what we want to do actually, we want to find a maximum path sum, and the path can go through any of the node from one point to another point in the binary tree. So if you take a look at these examples, 2, 1, 3, the maximum path sum would be 2 plus 1 plus 3. So the output is 6, right? It's getting a little bit complicated if you have negative number in the root node or any of the node, right? If you take a look at the constraint is actually the node value can be negative. So you need to be a little bit careful about that case case. Because if you're right to find the maximum path sum, and if you go through the root for this example 2, you will not be able to find the maximum path, because the maximum path sum would be actually 15 plus 20 plus 7, right? So if you add those three things, that comes to 42, which is the result here, output. But for that route, it cannot go through the root, because if you take root negative 10, it will basically reduce the number from 42 to maybe negative 32, right? And if you even add these 9, it will become 41. So you will not get the maximum value. So to recap, if you know how the post-order traversal works, and if you can figure out actually how to keep track of these maximum path sum, then you should be able to solve it pretty easily. But still, it's a hard problem since there are a few other SKs you need to keep in mind. So we will write one helper function, and we'll just copy it here and change the name. So we'll just maybe give this name as a find sum. And it will take a root node and basically return an integer. And so to get started, if your root node is null, you basically return 0, because there is no path with actually you can increase the value. So in the post-order traversal, you basically traverse the left node first, and then right node, and then the root node, right? So we'll do left subtree traversal first, and then right subtree, and finally process the root. So that's the idea of solving post-order traversal using recursion, right? And one thing to keep in mind, we want to find the maximum path sum, and it can be any of the subtree. So we need to be a little bit careful about that case. So how we'll do it? So from here, from the main function, we'll basically call this function self find sum with this root value, and we will return something. And we'll come back to here what we are to return. So for this problem, we will keep track of maximum sum, which would be on the class level. So we want to update max sum, which would be, we want to start with the negative infinity, so that if there is a case where you have only negative node, for example, only negative 10, right? So you want to return negative 10, not 0. So that's why you are starting the max sum as a negative infinity. And finally, we want to just return the self.maxsum. So let's talk about how we can write these 3 or 4 things, how we can process the root, how we can calculate the left subtree and right subtree, right? So let's draw these things, -10. We have the second example we are taking. We have 9 in the left side. We have 20 in the right side. And then 15 and 7. Right? So let's talk about what will happen actually if you have only the root node. So if you have only the root node, then your result should be -10 because you have only one node. So if you have only -10 and also this 9, what you want to do, right? So you want to traverse the left subtree, and your left subtree is something like here, and right subtree is basically total here, right? And this is your left subtree, which you want to traverse. And also that right subtree is here, so which we wrote in the code. So for left subtree, what we want to do, we want to traverse the self.findSum with basically root.left, right? And same thing for right subtree. But as I mentioned, there are some use cases you need to be careful. What will you do actually if you are in the left subtree? So just think about it. If your left subtree somehow return a negative value, for example, let's talk about -100, right? If it returns -100, what do you want to do? If it's returning -100, you can basically get a maximum value just excluding that negative number. So you want to find out what is the maximum value of left subtree and 0. What it does, the L returns the value. If it's obviously a positive value, you'll get the positive value from here. But if it's a negative value, you take 0 because you just want to discard the whole left subtree. And same thing for here. For right subtree, you want to do the same thing. If your right subtree return any negative value, for example, -10, for example, right? And what you can do, you can basically discard the whole right subtree and take 0. That means you can still get the maximum value. So you want to just, for the case of negative, you don't want to include in your final path, right? And when you are processing the root, how can you get the maximum value? You basically want to return root.value plus max of which part you want to take. You can go to either left side or right side, right? So for example, when you are in the picture, you are considering about this root node, right? When you are talking about this root node, you can go to the left side or right side. And if you want to find a path, you can take the either from this node, you can go to either left side or right side. That you will take only that part which will give you the maximum value. So what we are basically returning root value plus max of L or R. So you will take that path, either left subtree or right subtree path, based on the value what you are getting. So that's pretty much it for the traversal wise, but let's take a look at actually the maximum sum. So how we want to update that max sum. So this is the most important part. So processing the root, when you are processing the root, you basically want to do one more thing. You want to update that self.maxSum. And these will be the max sum of, you will check do you have the maximum sum already? Otherwise, you want to do L plus R plus root.value. So you are checking, do you have the maximum value already? If you already have maximum value, you don't do anything. Otherwise, the second thing you are checking actually, can I include the root value plus L and R and still create a sum which is more than what we already have, right? So for example, when you are coming from 15 and 7, you add these two things up and 20, right? So you get 42 from the left side, right? So your right subtree returned 42 here. Left subtree returned 9. So both are positive value, but the question is, do you update the self.maxSum? So if we add, so this is the special case, right? So if you add 42 plus -10 plus 9, that becomes basically 41, right? But you already have 42 in the right subtree. So basically you don't update that 42. If you can do that, then you basically save that temporary maximum value to the final variable, which will actually able to don't update if you get the lower value from that maximum. So a few key things to keep in mind. You should start with the maximum with the negative infinity, because if you don't start with negative infinity, then if you have a negative value like -10, -100, or -20, then you will get 0. So you want to start with a negative infinite number. Second thing, when you are updating the maximum, make sure you are only updating if you get a larger value by including the root. And if you don't find it, don't update this. So just keep that maximum. And these are pretty, the other part, how we are doing it, just a basic of the post-order traversal. You traverse the left side, you traverse the right side, and return the root value plus maximum of left or right, whichever side actually give you the maximum value. That's pretty much it for this solution. So let's talk about the runtime complexity. So you are basically going to the left side and right side. You are traversing only one node only once. So it will be order of n time algorithm. So order n. For the space complexity, if you consider the recursive call, it will have some stack complexity, but otherwise we only taking the maxsum, which is order of 1. So if you don't care about the recursive call, then actually it's order 1 space and order n runtime. That's it for this video. Thanks for watching. I will see you in the next LeetCode video.